So the span of the set of vectors v1 through vn is a set of all vectors that are sums of multiples of these. Then we write that general sum of multiples as c1 v1 plus c2 v2 and so forth, right? Okay? Now, what's the span of the set 2, 3, 1, -1, 5, 4? Well, span's a set of all vectors. Of this form, right? And that would then be 2c1 minus c2, 3c1 plus 5c2, and c1 plus 4c2. Okay? Now, a couple of things about this. Two, 3, 1 in three-dimensional space. Everybody's writing hard. I'm going to let you do that. Although remember, these things go up on the web, right? Incidentally, it might end up that I have to post these without giving them titles. Okay? Just because of time limitations, things that still need to be done. I'll give them titles if I can. So you might just see MVI 2358, 2359, and so forth. Okay? So if you choose to look at them, they might be in that form until I get to retitle. I'd rather go ahead and give them titles now because it's a pain to retitle them after they've been uploaded. But I can't guarantee I'll have time to do that. Okay, so we see this, right? Now what is this vector? If you think of vectors in three-dimensional space, it's 2 units that way, 3 units that way, 1 unit that way, right? So it's kind of in this direction. And what's this vector? -1 unit this way, 5 units that way, 4 units that way, kind of in this direction. So I got this direction and this direction, right? Now we've already done pictures. You see that to add multiples of these, I go either this way or this way on the line of this vector, and either this way or this way on the line of this vector, whatever distances I want, and then I combine the two to get another vector. They're going to be in a single plane, right? The plane of these two vectors, which is a plane that kind of makes this angle. Okay? If you don't remember that, review it. It's an important image. Okay? So, there's our vector V. Okay? So, my question here are there any vectors in R3 that aren't in the span? Well, from the hand waving I just did, all these vectors are going to lie in this plane somewhere. And there are a lot of vectors out of that plane that don't, that vector is not going to be in the plane. It's probably going to be pretty close to perpendicular. Okay? So intuitively you expect that there aren't. And you use your three-dimensional intuition a lot. Okay? So, are there any vectors in R3 that aren't in the span? how would you then show that algebraically? How would you show that there are vectors, that it's as you expect? There are vectors that aren't in the span.